difference is between those. Oh, we're gonna find one that works. So you have a finite and you have an infinite. Okay. First, let me look at a sequence. A sequence is a list of numbers. Okay? That's all it is. It's an ordered pair of numbers. It can, like 1 through 6, that's a sequence. They are always separated by a comma so that you know what they go in. Each part, each individual section is called a term. So if they say how many terms are in this sequence, we would say 6. There are 6 terms. Right? A finite sequence means that there are 6 terms. There is an end. We know exactly how many. So when we look at finite, finite means small, specific. That's what the word means. So if I were to do a comma and do ... and say this goes on forever, what type of sequence would that be?
Infinite.
An infinite sequence. Okay. So there are different formulas to figure out which different parts of our sequence terms. Okay. So you'll hear the terms direct, and you will hear the term recursive. Okay. A direct formula is one where we can find any direct term. So if I want to say find the 6th term of this sequence, and I have a direct formula, I can plug in my information and I can find the 6th term. A direct formula is always based on knowing the very first term. Okay? But it helps you find a direct term. Recursive, this is information. Let's kind of break this down. Re typically means again. Okay, so we're doing it again. Or it can also be, it can refer to something that was just behind because you're doing it again. So cursive refers to written, right? So if I'm talking about this term, I have rewritten it based upon the term right before it. So in a recursive formula, I have to know the term before so that I can write the term. I can rewrite the next term. Okay? That's the difference between a direct and a recursive. So if they ask you, is it a sequence that has a direct formula? If it's based upon getting a specific term with knowing the first term, that would be a direct. If it's a formula based upon knowing what just came so that we can know what's next, then that's a recursive. Okay? Those are the differences. So this will all make sense in a minute. I'm just kind of dealing with vocabulary. Okay? The next 2 things that we're going to deal with are arithmetic and geometric. Okay? What does arithmetic mean? In math.
Math, like algebra, right? And stuff like that?
Addition and subtraction,
Yeah,
right?
sure, yeah.
Reading, writing, you learn reading, writing, and arithmetic, right? Back in the old days.
Mm-hmm.
So arithmetic is simply addition and subtraction. So as we go through our sequences, if our numbers are moving in a steady rate according to addition or subtraction, then it is a arithmetic sequence. Okay? Geometric is multiplication or division. So if the rate at which they are changing is based on multiplication and division, we're going to do a geometric sequence. Okay? So the last thing with it, when we jump Let's look at this one. 2, 4, 6. When we jump from these numbers, what are we doing to each one?
Adding 2.
We are adding 2. It's arithmetic. Okay? The difference, the way that we find out what our jumps are, is by adding 2. Another way we found, how did you find that out, Nathan?
I know that.
When technically we did 6 minus 4 and got us 2, we could get 2, right?
Yeah.
And you do 4 minus 2 and get us 2. So this is called a common difference. Because we can take any 2 terms that are back to back and find the difference between them. That make sense? Common difference. Now, if I have 2, 4, 8, if I'm trying to see if it's arithmetic, well, this was plus 2 and that's plus 4. It is not an arithmetic sequence.
Why is it not? You're still adding.
Because they're not the same. They have to be the same. Okay?
So it's a geometric.
But if I go geometric, oh, this is really times 2, and that's times 2. Oh, that's the same. Okay? So it's through multiplication, so it's a geometric sequence. Right? This is called the common ratio. Okay? So with an arithmetic sequence, we are going to take 2 numbers that are in order, and we're going to find the difference between them so we can subtract them. With a common ratio, we're going to take any 2 sets of numbers, and we would divide them. So 8 divided by 4 would give us 2. If I took another set, if I did 4 divided by 2, I would get 2. So the ratio between any 2 numbers comes out to be the same. So that is a common ratio. The common ratio can be negative. It also can be a fraction, because it could be a half or 0.75 or whatever, okay? It's going to come out to be exactly the same each time, right? Now, for a sequence means numbers in a row. A sequence has to either be an arithmetic sequence or a geometric sequence. There has to be a common difference, or there has to be a common ratio for it to be considered a sequence. So if I have this set of numbers, well, I added 1. Oh, I added 4. Okay, that's not going to work. I multiplied times 2. I multiplied times 3. This is times 2. Okay, this is not a sequence. Okay, so if you have a list of numbers that do not have a common difference, they do not have a common ratio, it is not a sequence. It cannot be considered a sequence. All right? Got it? So exactly how do we really come up with sequences, and have we been doing them? Yes. Everything we've been doing so far can be written as a sequence. Because the terms will always be positive integers, okay? So each of our terms, so the thing about a sequence is each of our terms will be positive integers because they are numbered. This is our first term. This one is second, third, fourth, fifth, sixth, okay? So they are set up as integers. This is going to be important to know. They're always going to be positive integers, which means that they are counting numbers, okay? When we think about what we've been thinking about in math, we've been doing lots of functions, we've been graphing, we always have an x and a y, correct? We're used to this, okay? Our numbers that we have here, our terms are our 1, 2, 3, 4, 5, 6. They are considered our x values. It would just be like if we had a graph, right? When x is 1, what is y?
Oh,
Two.
oh,
It would be whatever we've decided. So in this case, we're going to set it up here. So here are our terms. These are our terms. Our values were 1, 2, 3, 4, 5, 6. So if we were to graph it, we would get a straight line, correct? So our integers are our x values. The numbers in our sequence are really like our y values, correct? What were other vocabulary that we used? We said our x values were also the domain, and the y values of a
Range.
function are our range. So if they say, what is the range of this sequence, it would be 1 to 6. Okay? Because that would be the y values, which are actually this. So let me make one where there's not the same. Let's do this one. So and there's still 5 rats. We do this one. Okay. The domain would be how many terms there are. So what is the domain of this one?
6.
6, because there's 6 terms, right? There would be 6 spots on the axis, on the x-axis. The range would be
2. Oh,
2 to
12.
2 to 12. So the range would be up to 12, okay? Again, because this is an arithmetic sequence, because I am adding the same, if I graphed it, what would I get?
Straight line.
A straight line. What you are, your common difference there just affects your slope of it, correct? So when we are graphing an arithmetic sequence, we are going to get straight lines. If you see a graph. They're going to be lines. Now, for a geometric sequence, because we are multiplying, so each term might be going up. So if we have by 2, okay, what is the domain of this sequence? 2, 4, 8, 16, 32. The domain is,
Times by 2. Or 2.
no, the domain, so how many x values do we have?
Oh, 5.
We have 5, okay. The range,
Is 2 to 32.
okay. You could say, no, probably just say 32. Okay, what is our common ratio?
2.
It's 2, because we are multiplying
2.
times 2. So our common ratio, we're calling it a ratio, is times 2. So if I were to graph that, when x is 1, y is 2, x is 2, y is 4, 8, we get a curve. We get a parabola. That okay? So these are going to be curved. All right. So there's all of the definition. So how do we actually put all of this new information into practice? Okay. Sometimes you will see a sequence written as a function, right? We can write it as a function because a function means we have a domain and a range, correct? Okay. Now, the reason that we work that is because what is the rule of a function? What is the definition? A function means that for every x value, we have only one y value, correct? So if we are working with a sequence and they are constantly going up with either a common difference or a common ratio, are we going to ever repeat a number? No. So for every x value, we will always have only one y value. So you can write it as a function. Remember, a function was like f of x equals something. Okay? Now, the thing that's different about sequences is we change some of the letters. Okay? That's why I wanted you to see what they're called in the first place, so then it makes a little bit of sense. Right? Because our x values here were our domain, correct? And we said they will always be positive integers, right? Because it's 1, 2, 3, 4, 5. That's the term place of it. Integers, we change our x to an n. Okay? So that is simply saying the place number. It's not the actual number, it's the place number, because that's our x value. You following with me? So you will often see, or with the sequence, it will say your n value. Your n value means which one. So in our example sequence here, if n is 3, what would our y be? If n is 3.
2, right?
If n is 3, 1, 2.
Or you say 6.
It would be 6. So if I had it in this way, it would be 6, because I'm looking at, if n is 3, my third term, 1, 2, 3. Then be 6, okay? Another thing that we do is, because we don't really have a y, so when we had f of x, it was just another way to write y, right? Because it is saying the answer when at the place on your graph where x equals something is equal to y. We call that a. So your y values are going to shift to an a. So instead of having f of n, it is written a of n. It'll be written this way. So this is simply saying the value at the n place, right? So if I have a of 4 for our sequence,
8.
a of 4 would be 8. A of 2 would be 4. Excellent. So we are now going to work within a of n. Okay. Another thing to notice, if I call this particular space, whatever it is, if I'm calling that space n, what would the space behind it be called?
N.
No, if this one is n, how would I know?
What comes before n?
N.
No,
Wait.
it would be n minus 1. Okay? I'm putting this out here so these spaces meet. So, if I am looking for the fourth space, if this is right, so we have 1, 2, 3, 4, 5. So I have my fourth term. My fourth term is my n. What's my term right before it?
N minus 2.
My third term.
Oh,
So how do I get 3? I need to take 4 minus 1. I need to go back
N plus
1.
1.
Right.
If you flip it.
So that's important for this recursive formula, because I'm just going backwards 1. So if I go backwards 1, I need to take my term, whatever term I have, and I need to subtract 1 from it. I need the term right before it. For fun's sake, what would the next term be?
A plus 2.
N
Plus 1.
n plus 1. Remember, I'm looking, these are my terms. Terms are always going to be positive integers. 1, 2, 3, 4, 5, 6. They're always going to be counting numbers. These are our y values. These are our x values. Our x values will always go up in counting. 1, 2, 3, 4, 5, 6, 7. Okay? All the way up. If it goes on forever, then we have infinite, and you might see the infinity symbol. You will hardly ever see that on a test, so we're not going to work with that one. Okay? So I'm going to put some up, and so we're just going to work a lot of examples. Okay? 3, 6, 9, 12, 15. Okay? What is a of 1?
3.
A of 1 is 3. A of 2
It's 6.
6.
is 6. A of 3
9.
is 9. Okay. So we are adding 3 to each one. Correct? So we can rewrite that. So if I think about this, I'm going to do, this is term 1, 2, 3, 4, 5. If my terms are my n values, so if this is x, think about it as x. And my answers, my sequence, are my y values, right? So this is a of n. How do I go from my n value to my y value? From my x to my y. If I had it like this,
Times 3.
it would be times 3, right? 3 times x. So the way that we write that is a of n equals 3n. Remember, we are replacing our y with a of n, because this says the actual sequence number of that place, which are x. So the formula for this sequence, the direct formula for this sequence is that the place, so if I wanted a of 30 for this sequence would be what? If I were to keep writing this sequence out and find the 30th
10.
term,
10. Right? 10.
it would be 3
Oh.
times 30,
Oh.
which would be 90.
That's
So if I kept with this sequence and wrote all the way down to 30 terms, on the 30th term, I would write the number 90. Our formula helps us have to not write all of those terms out.
So that's what you would use this for in everyday life? No, I'm not. No, actually,
Yes.
what you would use this for?
Yes, so because they might say, like you'll have the first 5 of a, and that's what we're going to work through, the examples on a test or an ACT or something. Or even practically, I've got a couple of practical examples, like if I am making so much each day and I double my profit, how much will I make on the 15th day? Like you may not want to write all that out. Or they'll say, what is the 42nd term? Well, I don't want to write out 42 terms. If I know the first few and I know my formula, then I can just plug it in. The 42nd term is this.
Right.
So again, if I had a of 100, in this sequence, it would be 300. 3 times whatever my n value is. So the 100th term, so this is the place, the 100th place in this sequence gives me a value, a whole value of 300. Okay? Remember, our n is simply telling us which place in the sequence. What we're coming up with is our value. So that's why it's good to think of it as like x's and y's, like, but your x's are always just going to be those counting integers. Okay. So we're going to, if we have a formula that says a of n equals 2n plus 3, here's a sequence formula. This is a direct formula because our formula is based directly on the term. This is a direct formula. Let's write the first 4 terms. What would a of 1 be?
5.
5.
Whoa.
Wherever I find, when n is 1, I'm plugging it in. So we're just doing the same as when we plugged in, if this would be f of x equals 2x plus 3, this is the same way we're thinking about it. When x is 1, y is 5. Okay? We've just renamed our x's and our y's. Okay? A of 2,
7.
okay?
So
A of
it's
3,
9.
perfect. And A of 4,
11.
11. To write this out as a sequence, our sequence would be 5, 7, 9, 11.
How do we get that?
What?
How do you know that A to A?
This is not an exponent. This is not an exponent. It's,
Well, how do we get 5 though?
how would we get 5?
How did we get 5?
Okay,
Two.
everywhere I see an n, I'm going to plug in the number 1.
Okay.
So 2 times 1 plus 3. It is just like,
Oh, okay.
so that's why I'm trying to show you, it is exactly like plugging in with our functions. This is why we already did functions before spring break. So that we can say, oh, well, on f of x equals this, what is f of 10? Everywhere I see a 10, I'm going to plug in an x, I'm going to plug in 10, and I'm just going to solve it. In the same way, we are just rewriting our f of x as an a of n. So the nth term gets plugged in. Everywhere you see an n, you would just plug that in, and then you get your y value. Right? Following?
Mm-hmm.
Okay, let's do another one. Okay. I have a of n is equal to
Lord.
okay, we're simply going to find our first 4 terms.
1 minus 1 is
A of 1,
negative 2.
0.
what is 1 minus 1 is 0. So
One.
anything to a 0 exponent is
1.
1. A of 2,
Negative
1.
Negative 1, so it'd be
Negative 2.
1 over 2, right? 1 over.
Why would it be
Negative
1
2.
over 2?
negative
wait,
2 to
yeah.
the 1.
Sorry, yeah.
A of 3. Now I've got 3 minus 1, so squared. So negative 2 squared.
It is negative 4. Wait,
4.
4.
4.
Oops.
A of 4.
4, 3.
8. 8.
Negatives, I can't.
Negative 8.
Okay.
2
Good.
times 2 times 2.
It's going back and forth.
Because it would be
five.
negative 2 to the 3rd. A of 4 would be negative 2 to the 3rd.
Yeah. So the
Okay.
next one would be 6.
So this is a direct formula for a geometric series. Okay? Because we are going by multiples. You see now we are this one is going by multiples. We are multiplying times
2.
Huh?
And then negative 2.
we're multiplying times negative 2. So when we look in our formula, where do we see negative 2?
The main.
Right
the
here.
base.
Okay? So as we go through and we learn the real formulas for it, this is our ratio. This is our common ratio. And that number will always tell you what you're jumping by. Okay, this goes back to our exponents and our logarithms when we were doing that. Okay, so we have our common ratio here. Okay, so now let's think about, I want to think about the practicality of how many we're jumping and why. Let's look at what this looks like. If I have 4 terms, so we have our terms, 1, negative 2, 4, negative 8. Okay? I have first term 2, 3, 4. I have 4 terms. My domain is 4. My range is negative 8 to 4 currently. Okay? How many times am I actually jumping?
By 2. Or times 2.
3.
How many jumps do I have? I have 4
3 jumps,
terms,
3 jumps.
but I have 1, 2, 3 jumps. I have 3 jumps of this common ratio.
So it's how many commas there are?
It would be how many commas, that's a good way to put it, how many commas there would be. It will also always be 1 less than your number of terms. So if I have 100 terms, how many sections do I have?
99.
I have 99. So I'm actually adjusting it 99 times. Okay? So it will always be n minus 1, your number of terms minus 1. If I have 26 terms, how many jumps will I have made?
25.
25. Okay, so this n minus 1 is telling us how many times we are jumping. Okay, just kind of like saying, I have a sheet of paper and I want to cut it into 8 sections. How many cuts do I make? You don't make 8 cuts, you make 7 cuts because you get an extra one, okay? So when we look at our formula, then we also look back, well, I've made this many jumps. This is telling me how many jumps I'm making. I'm going -2, and I'm going, this is what? -2 to the third, right? So on my 4th one, I jumped 3 times. From where?
1.
From the starting place. Our starting place here happens to be 1, so that makes it really easy. Our geometric formula for a to the n is wherever you start, and we call that a1, right? Why do we call that a1?
Because n is 1.
Because n is 1. Perfect. So this is a1, this is a2, this is a3. It's simply naming the term. So to find any value in a geometric series, I'm going to go from where I start, and I'm going to multiply that times my ratio, that will be called an R, your common ratio, n minus 1. So that looks super confusing if we haven't looked at what it really is. I am taking my ratio, my n minus 1 simply means how many jumps I've made. So it will always be 1 less than my total number of terms, correct? And then I have to multiply it times wherever I start. So let's look at this one and say, what would my 50th term be?
49.
So where's my starting? If I use my formula, I'm going to start at 1, right? I'm jumping -2, multiplying by -2. How many times am I multiplying by -2?
49.
If I'm finding my 50th term,
No, 49.
49.
Sorry.
So if I'm finding my 50th term, I'm going to jump 49 times. We're not going to work this out. What do we notice when our ratio is negative?
It flips back and forth.
It flips back and forth. It will always do that. So all even term places will be a
Negative.
negative. So will A50 be positive or negative?
Positive.
Positive.
No, wait. Well, technically it's 49, so.
It-
No, I am looking for A50.
Oh.
Then it'll be negative.
It will be negative.
Oh, okay.
A50 will be a negative. So if you know, if they say A176 of 2 times -3, which would actually be, so if they do this, okay, and they say A176, is it positive or negative?
It is negative.
My ratio is -3. That means each of my jumps is -3. Okay, I'm starting at a 2. That doesn't really matter. I'm positive, So every positive number is going to be negative. So if you had a list and they gave you A, B, C, and D, and they gave you, we'll just say 18, 27, negative 32, and 46, it can only be C because it's the only one that's negative. So do you even have to figure out the answer?
Nope.
No. I just know, oh, it's positive, my ratio is negative, then it's automatically
For
going to be
problems
negative.
like that, do you have to?
No, you don't have to figure it out. Like these are the tricks and tips to make.
But what if it's like you must show your work for every problem?
You don't have to show your work on any. You have 60 minutes to take 60 questions. That's why I like to show you the
Shortcuts.
shortcuts.
So you have more time with others.
So
So
you
you
have
just
time to
really
look at the
have
other.
to pass the test.
Mhm.
That's sad.
Yeah. So, okay. So now we've looked at jump. So let's look at, we figured out what we really look at for a geometric. Let's see if we can figure out what a basic arithmetic sequence would look like. Let's use our 2, 4, 6, 8. Okay. So what are we doing for each one?
Plus 2.
We are adding 2. Okay. So where do we start? If we start, again, remember, a direct sequence is always based on the first one, which we call a to the 1. So if I start at a to the 1, what do I do?
Equals.
I'm going to add
2, 3.
3.
I'm going to add a jump,
Oh.
right? Okay, our jumps for this one were our common ratio, we called it R. Our common difference, what do you think we call it?
C.
D.
D.
Oh.
Okay,
That didn't make sense. Sorry.
so I'm going to jump my common difference how many times?
3.
3 for this one, but my common difference will always be what?
4. Wait. 2.
The number of terms
Plus.
-1.
minus 1. Good job, Nathan. Woo!
Good job.
It will
That's
always be
equals.
the number of terms minus 1.
Wait.
Okay.
Doesn't it make? Wait.
Remember?
It will always be the number of terms times
Minus 1. Because
The
if
number of
I have
terms is
4
in?
if I have 4
Yes.
terms,
Cause
Okay, let's
eight
look at
is a number.
again, if I have 4 terms, how many jumps do I make?
Why don't you just put 3 minus
Well, because we're doing it generically.
1? Oh, okay.
This is generically,
It'd
okay?
be one.
So however many
Well,
terms
yeah.
I have, the number of jumps I have will be 1 less. Just like in this one, we wrote n minus 1 because it's, however, if I have 50 terms, I'm going to jump 49 times. 50 minus 1. If I have 50 terms here, I'm going to jump 49 times. We call it n minus 1. Okay, so our formula, we get it from whatever term. So if I want the 12th term, I'm going to find my 12th term. Okay? I can keep going down, or I can say I start at the number 2, and then I'm going to jump how many times?
What? 11.
11 times to get to the 12th one. And how many, and what am I jumping each time?
2.
2.
2.
24.
So 22, so my 12th term would be 24. So I started at 2, I jumped 11 times. Each time I jumped 2. So this is our generic formula for our arithmetic series. A to the n equals A1, and they actually usually put n minus 1 first, times d. Okay? Again, all of these random letters look really confusing until you know really what they're asking. Yes, Nathan?
Is the first 2 the starting number? Is that where you get it from?
Yes. It will always be, your A1 will be your starting value.
Starting value.
The starting value of your
Where it
sequence.
says A12 equals 2, where'd you get that 2?
That from the A1. So
Oh.
we go, so to find the 12th term,
Okay.
so to find the 12th term, I have to, where do I start? Where do I start? I always start at A1. A1 simply is identifying the first term. So I'm going to start at the first term, and then I'm going to add to it however many jumps I made, right? So this is the number of jumps. Oops, number of jumps times what I'm jumping by, right? What that common difference is. Right? Does that make sense? So you guys came up with the formula based upon what we were actually doing. And then we created it instead of just learning it and going, huh, what it is. Right, so let's put some of this into practice. First, I'm going to have you describe this one. Let's just look at series and see if we can start breaking down. Describe the pattern in this one.
Negative 1/3.
Negative 1/3 timesing negative 1/3.
So our jumps are multiplying times negative 1/3. Okay? So because I am multiplying, is it arithmetic or geometric?
Geometric.
It's geometric. Perfect. Okay? If this is term 1, term 2, term 3, and term 4, my terms are named my n's, what would be the formula that we could write for that?
AN equals negative 1/3 times.
Negative 1/3, not times. How many times? It's multiplication. So when we have multiplication, x times x times x is really x to the third. So when we have lots of multiplications together, we write it as an exponent.
So 4.
N minus 1. Right, or something like that?
Mm-hmm.
Yeah, N minus
4 minus
2n minus 1. Perfect.
1. Where's the ratio?
What?
Where's the ratio?
This is your ratio.
Is it also your A1?
Your A, what did we start with? Oh, on this one, our A1 needs to be put in as negative 1/3. So now we have it twice. So the true formula is negative 1/3, that's our starting point, times negative 1/3 to the n minus 1.
So ratio and.
In this one, the ratio happens to be the same as our first term.
Oh, okay.
If I started here,
It'd be 8. It'd be 1.
be different, right? Okay. Let's look at, I'm gonna go back to that. Okay, let's decide for this series. Is this an arithmetic series?
Yes.
Okay. Is this an arithmetic series?
3 plus I plus 7 plus. No.
No. So this is yes, this is no. Okay, so if this is an arithmetic series, what are our jumps?
Plus 4.
Okay. So our jumps are 4 each time. So what would be our formula? To find any term, we're going to go from where we start. What's our first term? Negative 3. And we are going to add 4 how many times?
1, 2, 3, 4, 5.
Well, in this one, we're doing generic in minus 1, right? So what would be our 10th term?
That'd be
-3 plus 4 times what?
9.
9. So I start at -3. I'm going to jump 9 times.
So 36.
36 minus 3. 8 to the 10th is going to be the number 33. Okay. So if we are given 50, 44, 38, and 32, let's write that. What's the formula there? What would be our rule? A to the n would equal what?
Okay, -6, right?
Okay, so we know our jumps are -6.
That's what we write first, right? Wait.
So where do we start?
Oh, 50.
We start at 50, and then we do what?
-3. Wait, -6?
Yeah.
Or
So
plus
we
6?
jump -6. How
And,
many times?
4? 3.
Well, we're doing the generic one.
And -1.
N minus 1. When something is written like this, you may see it distributed out, which in this case would be 50 minus 6n plus 6. So we could write a to the n equals 56 minus 6n. Okay? Sometimes they will say simplify or find it, and you won't find this first one. You will find it when they have distributed out this n minus 1. Okay, just to be aware. Got it? So we start at 50. We are jumping -6 how many times? So what is a to the 20? We're starting at 50. We're jumping -6 how many times?
19.
19 times. So I have 50 minus 114, which equals -64. Right? Is it making sense? Not quite as confusing as it possibly could be. Okay, so here's a word problem. If a concert hall has 25 seats in the first row, okay, and every row thereafter has one more seat. Okay, we're going to keep going up. There are 32 rows. So that tells us there are how many terms? 32, because we'd go 1, 2, 3, 4, 5. If we were to set our sequence up, it would look like 25, 26, 27, correct?
Yeah.
Okay, so here's our terms. We're going all the way to 32. Right? So these are our A of N's. Here's our sequence answers. Okay. It says write a rule for the number of seats in the nth row. I want to know how many seats are in the 17th row. Okay. How would I write that formula? Well, first we need to figure out what are we doing? What are we jumping?
1.
Plus 1. So since we are plus 1, we go from where we start. Where do we start?
25.
25. Then we are adding what?
N minus 1.
Yeah.
Right? No, n plus 1? Wait.
1
1. Yeah, sorry.
times how many? However many jumps we have, correct? Okay. So here's our formula. And it says, which row has 35 seats? So I want to find out
11.
35. Right? So that's how many, right? Because that's my answer here. 35 is in which row? Let's multiply this out. N minus 1, right? I just distributed that.
Yeah.
So I really have 24 plus N equals 35. N equals
9, 11.
11. Row 11 has 35 seats. Okay? So if it says a class with 32 students wants to all sit together on the same row, which row could they sit on?
11. Wait.
Wait,
how
how many
much?
students?
32.
Students?
9. No, 8.
So we would do 32, which row has 32 seats? Where I'm starting, how many jumps? I'm jumping 1
24
times how
plus
many
what?
times? So 24 plus N equals 32.
8.
N equals 8. They could sit on the 8th row. That's as close as they could sit to the front.
Oh,
They all wanted to sit together.
It's a big class.
a little bigger than ours.
All right. So those are arithmetic sequences. Okay. We looked at the geometric. Let's go over some practical problems with this one. Okay. We know that our jumps are called a ratio. They're called a ratio because the difference between any two numbers can be written as a ratio. One number divided by the next. It should all be exactly the same. So if we have 2, 6, 18, 54, what is our common ratio?
Times, 3.
Our common ratio is 3. We are multiplying times 3. So how do I get each number? 1, 2, 3, 4.
Times 3.
I'm going to take the first one, right, where I start,
Oh, yeah. 2,
and I'm doing,
3, and minus 1.
there you go, to get there.
Yeah.
Right, so any term in this one would be where I start. I'm going to jump 1 less, and every time I jump, I'm going to jump by a 3. Right, so let's look at 749, 343, 2401. What would be my 6th term?
Whoa, a big
Okay.
number.
Yeah, a really big number.
So what is where are we starting?
7.
We start at 7. What are we jumping?
7.
Times 7.
Oh.
And how many times are we jumping?
5.
5. We're jumping 5 times. Perfect.
Oh, that's
Alright.
a big number.
Okay, so 7 times. Okay.
Okay, so it's whenever you have your starting number the same as your common ratio, it can look a little confusing. Okay, but we started at 7. We're jumping by our ratio how many times? 1 less than where we're at. Okay, if we go, someone want to do this one on the board?
Micah does. Oh,
Yeah, that's a big number.
Okay, write the direct formula for this one.
Where's the marks?
Oh, this one. There you go.
Okay. A and good.
So first, is it an arithmetic sequence or is it a geometric sequence?
It's arithmetic.
It's arithmetic.
3.
So where do I start?
And
Perfect.
then
Nope. It's arithmetic, so we need to
plus it.
add.
Plus.
That's why it's important whenever when I'm showing you the jumps,
I think it's more.
And
when you have your jumps, on this one we're adding 35. So this sign is what goes here. If we were multiplying, then that's the sign that goes there.
So that's right.
Plus 35 n minus 1. Okay. So 35 plus 35 n minus 1. Excellent. Okay. Nazarene, come do this one. 4, 48, 5, 76, 69, 12. No. The first thing you need to find out is what is the sequence doing? Is it adding? I don't know. Well, if I went from 48 minus 4 would be 44. Is the difference here 44? No, so it's not adding. How can we find out what it is? First, we need to find a difference. So 48 minus 4, is that the same as 576 minus 48? No. So the other way is to look at our common ratio. Ratio means to take any two numbers and divide them. Okay. Right, so is that the same? 48 divided by 4 is 4 goes into 4. How many times? 4 goes into 8. Okay, 12. 576 divided by 48 happens to be, and this happens to be 12. So, do we have a common ratio? Yes, so your jumps are times 12. Perfect. So to find any number, just a to the n, so finding any term, any place, we're going to start at, and then we're going to do what? We're multiplying how many times?
That's all I had.
Okay. So in this one, she wrote 4 times 12 times n minus 1. Let's think back. If I am jumping 12 times, let's just call it x. And I'm jumping the same again, x. And I'm jumping the same again. So I have x times x times x. How would I rewrite this? X times x times x. X cubed. Okay? So the number of jumps is an exponent when we're multiplying. So the n minus 1 is an exponent. Okay? This is why it's an exponent. If we are jumping the same amount, we're multiplying it each time, I would end up with x cubed. So I end up with an exponent. So we need to make sure that the number of jumps are an exponent. So perfect. We're starting at 4. Good job. We're jumping 12 each time. We are multiplying our jumps because this is a geometric sequence. So we would jump, that's the exponent of the 12. Okay? So if we wanted to find the, yeah, so say we wanted to find the fifth term. We would do 4 times 12 to the fourth. So I'm going to find the fifth term, so I'm going to jump 4 times, and then you would figure that out.
A big number.
Okay?
It's like 10,000 right now. It's like, wait.
So how do we go backwards and find something if they don't give us the whole sequence? Right? When they only give us parts of it. So if they say find the nth term, if they only give you one term, a to the 3 equals 5, and my ratio equals 2.
Oh, you can do that.
How would we find that?
From the ratio.
Well, I know that, and we're going to call this a geometric sequence. Okay? So I know that for any value, it's wherever I start times my ratio to the n minus 1, right? So in this case, I have a to the 3 is equal to my first one. My ratio is 2. what would I be? It would be squared, right? 3 minus 2. And that is equal to
5.
5, right? So now I can solve for my first term because I have 4a equals 5, a to the 1 equals 5/4. So the first term in this series would be 5/4 or 1.25. Okay? Do you see how we were able to use our knowledge of our formulas and find out what it is? Okay. How do we find our first term if they just give us 2 terms? So if a to the 2 equals 45 and a to the 5 is negative 12/15, what do we know? We know that any term is equal to wherever I start, a to the 1 times my ratio.
We don't know the ratio, right?
Raise. We don't know the ratio. Okay, so let's think about this. So I have a to the 2 would equal a to the 1 times r to the first, right?
Yeah.
And then I also know that a to the 5 would equal a to the 1 times r to the
4th.
r to the 4th. Okay, well this one is equal to 45. And this one is equal to negative 12/15, right? I have 2 terms here. I can solve for one and then I can substitute, right? So now we have system of equations. We're gonna solve, it's gonna be easier to solve for the a to the 1. So a to the 1 here, because r to the 1 is simply r,
Or yeah.
right? A to the 1 is equal to 45 divided by r. So I'm going to plug that in over here. So I have negative 12/15 is equal to 45 over r times r to the 4th. Can we simplify this? What are our rules of exponents? Exponent divided by an exponent. Subtract them, right?
Yeah.
Because this one cancels out 1 up here. So I have negative 12/15 equals 45 r cubed.
Still don't know what r is.
How do I solve for r?
Divide by that.
Okay, we're just using our regular, nothing new. We're using our regular rules.
And then square root or square cube.
Now I need to take the cube root of
Cube
r
root, that's what's
cubed,
wrong.
cube root of this side.
It's 3.
R
Negative
equals
Or 3i.
negative 3.
Wait. Why does it be 3i? Because the negative inside.
Nope, because this is actually negative 3 to the 3rd.
Ooh. I thought negatives inside. Wait.
If it was a square root.
Okay.
Yeah, but that's a square root. This is a cube root. Okay, so our ratio is negative 3. Okay, and then we could go back and find any first term. So we can use what we know about our formulas, no matter what they give us, to find other answers. Okay? Okay, let's work through, we have 15 minutes.
A1 is 45 divided by 3,
Okay.
right?
These are some, okay, I want to hit, we're going to hit
Negative
one more example, an
This is a
ACT
negative
example, and then I'm going to go over summing. Okay? So what is the difference between each term of a sequence if the first term is negative 6 and the 12th term is 126? Okay? They'll give you this. What is the difference?
The difference?
So we could
120.
say, no, what is the difference between each term
Oh.
if the first term is negative 6 and the 12th term is negative 126? Or is 126?
Oh, never mind.
Does it?
All right? So initially we're like, okay, so we start guessing.
We add
Okay.
10 of it.
Or I know that any term, right? Because they're saying the difference between each term. So I'm looking at an arithmetic sentence. Any term is wherever I start plus however many jumps I have, right? So if my 12th term is 126 and I start at -6, I don't know what my common difference is, but I know I'm jumping how many times?
12, 11.
11 times. So now we simply solve. 132 equals 11D, D equals 12. The difference is 12. Done. Sounds very confusing. Okay, what are they really having me to do? They're saying, what are my jumps? I know how many times I'm jumping. I know where I start, and I have an answer for a direct end.
So they just add 12 every time?
Yep, so the difference would be to add 12.
Okay.
They're not asking you to find out a certain one, they're just saying, what's the difference between it? Okay? Summing. Summation will look like this. This is the sigma symbol.
What is it?
It looks like a. Never mind.
Anime.
Yu-Gi-Oh!
Okay, they will put whatever your formula is here. Whoa, and they will say to sum terms 1 to 6.
Those kids.
Okay? It will look like this. Something like that. This means to sum up things. I'm going to show you a trick of what sums really do, because if you see a summation, it will usually be less than 12 terms. So we can either, there's a formula for it, or you can work it out longhand. Okay? If I have 4, 7, 10, 13, 16, 19, and I want to sum all of these up.
Add them together?
Because this is a series, and because each jump is exactly the same, you have pairs of numbers that are exactly the same. 19 plus 4 is 23, 16 plus 7 is 23, 10 plus 13 is 23. Your first term and your last term added together will be exactly the same as your second term and your second to last term.
What if it's odd?
Okay? Right. So, if I wanted to sum this up, all I have to do is add my first and last term and multiply it times half of my number of terms. Correct? So if I have 10 terms, how many sets would I have?
5.
I would have 5 sets. So the summation here would be 23 times 3. Right? Would be 69 if I added those all up. Okay? So anytime, so the formula for summing any terms looks like this. Let's look at why it looks like that. I'm adding my first term and my last term, right? I'm taking my number of terms and I'm dividing it by 2 because I'm breaking it up into pairs. I never remember this. I just remember the practicality of like clicking it out together. Okay, so if we have a problem that says Andrea is selling boxes of cookies door to door. On her first day, she sells 12 boxes of cookies. She intends to sell 5 more each day. Okay? If she meets her goal and she sells cookies for 10 days, so we've made it to n equals 10, right? How many cookies did she sell altogether? So what do we need to know first?
50.
We need to know how many cookies she sold on that last day. So how do we find out how many cookies she sold on the last day? A to the 10 equals what? Which one are we doing? Are we arithmetic or geometric?
Arithmetic.
Arithmetic. So it's where I started
12.
plus what I'm jumping by
5.
for how many days?
9.
9 days. So A to the 10 equals 12 plus 45. So on the 10th day, she sold 59 cookies. Cookie boxes. Right?
47. 57.
57. You were right.
I was like, I asked it.
Sorry, 57.
Like a 7 or 2.
Okay? So now, how many cookies did she sell altogether? Do we need to find all of these other numbers?
No.
No, because we know that our first and our last will be the same as we pair them up. Okay? So 57 plus 12,
69.
69. And how many pairs do I have?
5?
4.
5 pairs. Because I have 10 days, so I have 5 pairs. So 69 times 5
Do not say it.
is 345. She sold 345 boxes of cookies.
I was gonna get to it.
Okay, so long ways, you could do 12, she's 17, and 5, then 22. You could write all your numbers and then add them up. So it is possible to do it the long way. Or we can simply use what we know about sequences.
Yeah, we don't have enough time on the test to do
Yes, you wouldn't have enough time on the test to do that. Okay, so let's look at another, yeah,
5 minutes.
5 minutes, okay,
Oh,
good.
It's lunchtime.
It's almost lunchtime. Okay. What is the first term in a geometric sequence? So first off, we're looking at geometric. So I know I'm where I started times my ratio to an exponent, right? However many times of my ratio. If each number is found by multiplying the previous term by -3. So what have they just given me?
The arithmetic thing.
They just gave me the ratio
Ratio.
is -3. Okay.
Word.
And the 8th term, so into the 8th is 4374. And they want to know what is a to the first.
You just keep dividing that by 3.
8th. Yes, you could
But
divide by
you
3,
have
divide by 3, divide by
enough
3.
time to do that.
Okay. Or I know that a to the 8th is now my first term, which I'm looking for. -3 to how many times?
7.
To the 7th. Okay? And that's equal to what?
-21.
4374. So now I have only one variable. So I would find -3 to the 7th. I would divide 4374 by -3 to the 7th, and we get -2. So we start at -2. All right? See how that works?
Planned it to be -2 or something.
Okay. So there are, you have a print sheet of 10 questions to work through.